All right, guys, welcome to virtual chemistry. So I'm going to do a little bit of review of assigning oxidation numbers. Then you're going to learn your lesson for today. You still do have a quiz tomorrow. It's 2 questions, and I'll tell you what the quiz says. And then we'll go through a little bit of practice, and then you have a worksheet to complete. So first things first, in order to understand redox well, you need to get really good at assigning oxidation numbers. Oxidation number is just a number to keep track of electrons during bonding. So what we did was we learned a bunch of rules for them, and then we learned how to set up algebraic equations so we can solve and figure out whatever the oxidation number of something is. So first things first, we have methane right here. So I'm going to list off each atom because, again, all I want to know is what is the oxidation number. So with this, you always want to start with the atom you have a rule for that you know for sure. So hydrogen is in group 1. Group 1 is always +1. Now, carbon's one of those weird ones that if you look it up on the periodic table, you have so many options. So we don't know what carbon is, so I'm going to call carbon X. And so if I add carbon's charge to hydrogen's total charge, all of that should equal up to 0. So that's how I'm going to solve to figure out what X is. So I'm going to add that to hydrogen's charge, which is +1. And because I have 4 hydrogens, I'm going to multiply that by 4. And all of that is equal to 0. So my algebraic equation turns into x plus 4 is equal to 0. X is equal to -4. So that means carbon's oxidation number is -4. Same thing over here. We're going to go with nitrite. Nitrite has nitrogen and it has oxygen. Now I know for sure oxygen is -2 because that's one of my rules. So now I'm going to use that as like a starting point to figure out what the charge of nitrogen is. Again, I don't know what nitrogen is, so I'm going to call that X. So I'm going to add that to whatever the net total charge that oxygen is contributing. So oxygen has a -2 charge right here. And so I'm going to take that oxidation number and I'm going to multiply it by the amount of oxygens that there are. Now this time I can't set the entire equation equal to 0 because nitrite has a charge of -1. So that means whatever the sum of these two things is, it has to equal -1. So this turns into x minus 4 is equal to -1. I'm going to add 4 to both sides of the equation. So I get x is equal to +3. All right, last but not least, we have phosphate. So phosphate is another polyatomic ion, meaning it's going to have a net charge of -3. So let's list off phosphorus. We have oxygen. Oxygen is always -2, so we'll start there. Now I don't know what phosphorus is, so I'm going to call that X, and I'm going to add it to the net total charge that oxygen is contributing. So oxygen we know is -2. However, there's 4 of them, so I'm going to have to multiply that by 4. And so whatever this side of the equation is, it has to equal -3 because it has to equal this net charge. So this turns into x minus 8 is equal to -3. So x is equal to +5. Okay, so that's assigning oxidation numbers. And again, that's really important because a redox reaction is basically when you have the transfer of electrons occur throughout a chemical reaction. So there's 2 main processes that occur during a redox reaction. You have oxidation and you have reduction. That's why it's called redox. So in order to understand what oxidation and reduction is, you have to remember the phrase, Leo the lion says grr. The reason for that is oxidation is when a species loses electrons during a chemical reaction. So what that means is lose electron oxidation. When you lose electrons, you are becoming more positive. So you might want to make a special note. That means you're becoming more positive because electrons are negative. So when you lose negativity, you become more positive. On the flip side, so we know Leo is lose electrons oxidation. So Leo the lion says grr. So now we need to understand what grr stands for. Grr stands for the other part of redox. It stands for gain electrons reduction. So that means our definition of reduction is a species that's going to gain electrons during a chemical reaction. So this species is going to become more negative. So your quiz tomorrow is going to be a picture of Leo the lion, which I'll show you. He looks like this. And what I want to know is I want to know what is the lion's name. It's Leo, lose electrons, oxidation. And I want to know what the lion says. He says GER. Spelling counts, it's G-E-R and L-E-O. So that's important because now we're going to get into chemical reactions and we're going to see a little bit of redox happening. So in order to understand redox, you need to start with oxidation numbers. So I'm going to go through this chemical reaction and I'm going to assign oxidation numbers. Magnesium is a free element, so it's 0. Oxygen's a pure element, it's diatomic, it's 0. Magnesium is in group 2, so it's +2. Oxygen has a charge of -2. So now what I want to do is I want to figure out which species is undergoing oxidation and which species is going under reduction. So magnesium goes from 0 to +2. So that means it lost 2 electrons. Now, according to Leo the lion, lose electrons is oxidation. So magnesium is undergoing oxidation. On the flip side, oxygen is going from 0 to -2, so it's becoming more negative, so that means it gained. And according to GER, gaining electrons is reduction, so that means oxygen is undergoing reduction. And that is your quick crash course on redox.